pipes in piping system. Now next component is union. See here union, reducing unions, and there is a female union, male unions, 90-degree unions, and reducer unions. So with the help of this reducer, or we call the re- for reducing pipe size, has two female connection into which the different size pipes with the help of reducers may also be made with one connection eccentric for free drainage of water. So here with the help of this reducer we can connect uh, pipes pipes, but we can slightly reduce the piping size. So that kind of fittings are used in piping systems. In union, so in union, if you considered for providing an easy method for dismantling piping system. So with the help of union, we can easily dismantle with the help of 90-degree unions, or we can consider the reducing unions. So we can reduce, and one more is female union and male union. So we can provide an easy method for dismelting the pipe system. So we can easily dismelt the pipings in plant industries, chemical industry, or petrochemical industry, or hydrocarbon facilities. Now next component is T's and crosses. So here you can observe the T's, that is a reducing T. Next one is a T, and one more is a reducing T. Slightly their direction has been changed when we are considered for reducing. So with the help of this T and crosses for making branch line connection at 90 degrees, see, all are 90 degrees. So here we can form the branches with the help of T and crosses, so that we can consider different branch line connection at 45 degrees, 90 degrees. And then next component is a Y bend. So that kind of Y bends are used. Y bends are generally manufactured by MSS-SP, that is manufacture the standards. As per requirement of industry, we can manufacture the Y bends. What is the use of Y bends? For making branch line connection at 45 degree, and T and crosses for making branch line connection at 90 degree. See the difference. Y bend and T's and crosses. With the help of T's and crosses for making branch line connection at 90 degree, and Y bends for making branch line connection at 45 degrees. And next is a return bends. So with the help of return bends for reversing direction a pipe run. Whatever pipe is there, so we can reversing the direction of pipe run. So for this purpose, we can use return bends. Next component, plugs and caps. So here you can see the caps. So and plugs, with the help of these components for closing of pipe ends or fittings. With the help of pipe plug and caps for closing of pipe ends or fittings. There is no extension in pipelines or in pipe runs with the help of plugs and caps. Now next component is a bushing. So we are use a bush for connecting pipes of different sizes. The male end is into coupling, and smaller pipe is then screwed into the female end. The smaller connection may be tapped eccentrically to permit free drainage of water with the help of bushing. So with the help of bushing, so we can use that connecting pipes of different sizes. And male end fits into coupling. See here coupling. So here you can fix the bushings. And the smaller pipe is then screwed. On other end, there is a smaller pipe is then screwed into female end, and the smaller connection may be tapped eccentrically to permit a free drainage of water. Now next component is a reducer. In reducer, for reducing pipe size, has two female connection into which different size pipes. With the help of a reducer, or reducing size has two female connections into which different size pipes fits. May also be made with one connection eccentric for free drainage of water. So this is all about pipe fitting components. First one is elbows, next is nipples, couplings, unions, T and crosses, Y bends, return bends, plug and caps, bushing, and a reducer. So these are the components we can use for fittings in piping systems in chemical plants or in um, petrochemical plants or hydro plants. Now we'll start with pipe size. During here earlier during early years of the oil and gas industries in the United States, the dimensional system was known as iron pipe size, that is called as IPS. Earlier, uh, this system is used in oil and gas industries in the United States, and it was called IPS, that is iron pipe size. The size identified the approximate inside diameter of the pipe in inches. For an example, so here IPS 6 means iron pipe size 6. So here has an inside diameter of approximately 6 inches. And these IPS sizes had the wall thickness that were identified. See, so wall thickness that were identified as standard weight. So can abbreviate the standard weight STD and WT. Stands for standard weight, is required for lower pressure piping as per ASME class 150 and 300, and extra strong, so it is denoted by XS, or extra heavy, it is denoted by XH, for medium pressures using ASME class 600. And next schedule, that is a double extra strong, that is XXS, it is denoted by, or double extra heavy, we can designate XXH, for high pressure ASME class 900 and above. So here we can use the schedule. Schedule represents the wall thickness in piping industries. So as the oil and gas industry develop more and sophisticated new materials were developed and became available, such as carbon steel in its various purpose use, low and intermediate alloys, and corrosion resistance alloy. We can use low carbon steels, low and intermediate alloys, and corrosion resistance like stainless steels. The original dimensional system required updating to accommodate the improved characteristics. The improved characteristics and that these new materials abroad. Corrosion resistance alloy mean that corrosion allowances could be reduced. Corrosion resistance means we can reduce the corrosions, and in many cases dispense with resulting in reduction. See here the corrosion allowances we can reduce resistance, so dispense resulting in reduction of the wall thickness and less weight. So these thinner walls, see these thinner walls, we can designate it as a nominal pipe size, and therefore the expanded range of pipes of this size and the wall thickness of this expanded range of pipes, the new designation known as nominal pipe size, and replace the terminology, earlier terminology, that is IPS means iron. This terminology iron pipe size we replaced. And then term schedule was applied here was applied to specify the nominal wall thickness of pipes. Essentially, nominal pipe size is a dimensionless designator. NPS2, for an instance, here NPS2 indicates a pipe whose outside diameter is 2.375 inch, and the NPS 12 and smaller. Here, other example, NPS 12 and outside diameter greater than the size a designator, that is 2, 4, 6, 8, 10. Larger pipes is the same, and the size designator in inches. So for this purpose, we can use here greater than 12 inches. That is, being the diameters greater than size designator 2, 4, 6, 8, 10, and 12. However, the outside diameter of NPS 14 and larger pipe is the same as the size designator in inches. For an example, NPS 40. If you consider another example, NPS 40 has an outside diameter equal to 14 inch. If you consider the outside diameter of NPS 40 and then outside diameter equal to 14 inch. The inside diameter depends on the pipe wall thickness, means schedule, specified by the schedule numbers. So the schedule numbers we can refer to ASME B36.10 M or ASME B36.19 M. In spite of introduction of the schedule method for identifying the wall thickness of pipe, that is STD. Earlier we are considered schedule, that is identifying, that is STD, that is the standard, or single X in bracket XH and double X S in bracket double XH. So with the help of uh, we can identify the wall thickness of pipes, and at certain sizes there is a correlation between standard and schedule 40 and XS and schedule 80 and double XH schedule 160. But always check and never guess in uh, piping industries. In metric unit systems developed by that kind of metric systems developed by the International Standard Organization, so we call ISO. So in table, so here we are given the diametral, that is nominal diameter and nominal pipe size. So here we can see the cross reference between NPS and DN, that is a metric units in millimeters. So dimensional specifications, pipes used within a plant design one of the various ASME B31 codes, and generally are manufactured to set of required specifieds. In one of two American societies for mechanical engineer standards, depending on the material for constructions, that is B36.10, welded seamless rod steel pipes, carbon steel pipes, low temperature carbon steels. As per ASME B36.19M, stainless steel and stainless rod steel pipes covers the standardization of dimension of welded and seamless rod steel pipes. So these are the material specifications. So we can consider kind of materials as per the ASME B36.19 standards, and stainless steel pipes covers the standardization of dimensions of welded and seamless wrought stainless steel pipes. The word pipe, as distinguished from tube, is used to apply to tubular product of dimensions commonly used for pipeline and piping systems. Pipe dimension of size 12 and smaller have outside diameter numerically larger than the corresponding size. Now here material specifications. In material specification, the most commonly used pipe material in the oil and gas industry is carbon steel. So carbon steel is widely used and chemically modified version for operating at temperature down minus 46 degrees Celsius. Apply are called low temperature carbon steel. So which stands for LTCS means low temperature carbon steels. Both version of carbon steels combine strength and a basic level of resistance to corrosion services. In slightly more corrosive service, an additional calculated corrosion allowances, it stands for, we can call CA, can be added to the wall thickness of the pipe called corrosion allowances. The corrosion allowances increment usually in piping industries that is 1 or 16 inch. If you convert into millimeter, that is 1.5 millimeter, and 1 over 8 inch, or 1 over 4 inch, that is 6 millimeter. And it is very rare for the corrosion allowances means CA to exceed 1 or 4 inch, because a more corrosion resistance metal will be specified. That is the reason it will not exceed above 1 upon 4 inch. It is very rare for the CA to exceed 1 over 4 inch, because a more corrosion resistance metal will be specified. So this is all about the material specification used in piping industries. Now next is methods of connecting. So here there are three general methods used to join or connect lanes of pressure piping in piping industries. For instance, chemical plants, petrochemical plants, or in hydrocarbon facilities. First method is the screwed connections, and second one is the flange connections, and third method is welded joints. Each of these methods has certain advantage and disadvantages, and each will be discussed in detail. Screwed connection, first method, that is the screwed connections. In this method, the threads are cut on each end of the pipe. What we'll do here in this method, threads are cut on each end of the pipe, and screw fittings such as union, couplings, and elbows are used to join the lanes. Earlier, we have seen the pin piping fittings, that is unions, couplings, and elbows. See, here we can use the elbows, couplings, and unions to connect the pipes with the help of screwed connections. Means here, screwed fittings such as union, couplings, and elbows are used to join the lanes. This method is generally used for pipe size less than 101.6 millimeter, or we call in inches, that is 4 inch. This first method, screw methods, is used for pipe size less than 101.6 millimeter. If you convert this millimeter to inch, that is 4 inch, for low and moderate pressure. See, this is the purpose. It is used for low and moderate pressure. It has the advantage that the piping can be easily disassembled. or assembled with the help of screw connections. However, the threaded connections are subject to leakage and strength of the pipe is reduced when threads are cut in the pipe wall. This is the disadvantages. An advantage is we can use this method and to connect the pipe sizes less than 101.6 millimeter or 4-inch for low and moderate pressure. As the disadvantage, the pipe can be easily disassembled or assembled. This is the disadvantage. And another is a threaded connections are subject to leakage and strength of the pipe is reduced when threads are cut in the pipe wall. See the advantage and disadvantages of screwed connection. Now next method is a flange connections. So in flange connection uses the flanges at the pipe ends. In next class we'll see the different kind of flanges. So here in this method uses the flange at the pipe ends which are bolted together face to face, usually with gaskets between two faces. For an instance, if you see the pressure cooker, there is a gaskets. This is a circular shape in gaskets. So same kind of gaskets we can use in pipes. So we can bolt together face to face, usually with the gaskets between two faces. Flange connections have the advantage over welded connection. What is the advantage over the weld connections of permitting disassembly and more convenient to assemble and disassemble than the screwed connections in order to prevent leakage at flange connections. So in earlier method, so there is a leakage and strength of the pipe is reduced when threads are cut in the pipe walls. But with the help of flange connection, we can overcome on these disadvantages. We can fix the gasket between the two faces and flange connection. The advantages or welded connections are permitting disassembly and more convenient to assemble and disassemble than the screw connection in order to prevent leakage at flange connection. The flange faces which butt together. So here we have to use the butt weldings would have to be absolutely flat and smooth, while it is theoretically possible to grind the faces. Need to grind the faces of flange to this condition, and it is a time consuming and expensive proposition. So in terms of we are consider material, time, and economic factors, so it is slightly time consuming and expensive. Therefore, gaskets are usually used between flange faces. That is the reason why we are use gaskets between the flange faces. And gaskets are made up of comparatively soft materials. So here we can use soft materials to manufacture the gaskets, which when the flange connection is tightened, will fill in any small depressions in the flange face and thus prevent leakage. So for the flange connection methods. Now next method is welded connection. In welded connection, in this method, the pipe lanes and welded directly to one another and directly to any walls or fittings that may be required in welded connection. The use of these welded joints for piping has several advantages over the use of screwed connection or flange connection. See, the possible of leakage is removed with the elimination of screwed connection or flange joints if we use welded connection methods or weld joints. Now, next advantage over the use of screw connection or flange connection. Here, weight of the piping system is reduced due to the elimination of connecting flanges or fitting. See, another advantages of welded connections or welded joint methods of connecting pipes. So, here we can reduce weight due to the elimination of connecting flanges or fittings. Now, third, cost of material and the need of maintenance are reduced. See here, cost of material and need for maintenance are reduced with the elimination of flange and fitting. So here we can eliminate or reduce the flanges and fitting components while using the weld joints or welded connection in piping system. So therefore, we can reduce the cost of material and need for the maintenance are reduced with the elimination of flange and fittings. Now, fourth advantage, that is a pipe looks nearer and easier to insulate with the elimination of bulky flange and fittings. So here we can reduce the bulky flanges and fittings with the help of welded joints or welded connection. But this requires skilled uh, person, so he can weld a thinner piping systems in piping plants. So that we can reduce the bulky flange and fittings. Now, fifth advantage of welded joints or welded connections. So, welded joints gives more flexibility to the piping design as the pipes may be joined at practically at any angle to each other. So, with the help of welded joints, so it gives more flexibility to the piping designs. The pipe may be joined at, in at any angle to each other. So if you consider 45 degrees, 90 degrees, 30, 60 degrees as per the requirement in the industries, means in oil and gas industries or in chemical plants or in petrochemical plants or hydrocarbon facilities with the help of welded joint connection. So we can use any angle to each other. So therefore, welded joint gives more flexibility to the piping design as the pipes may be joined at practically any angle to each other. So main disadvantage of using joints of piping is the necessity of obtaining a skilled welder. So this is the disadvantages using the welded connection or welded joints. We require skilled welders whenever a connection is to be made. This is the biggest disadvantages using welded connection. So today's lecture is covered piping fittings and material specifications, method of connecting pipes, and pipes size. So if you have any questions, any doubts, so you can ask your questions, doubts. So in last 15 minutes, we'll discuss your question answers. Yes. Yes, Tanmay. Do you have any questions, any doubts?
No, sir. No doubt.
Okay, Arnav, do you have any doubts? Pipe fittings, material
No,
specification,
sir,
pipe
no doubt.
size,
No doubt.
and method of connecting pipes.
Yes, sir, no doubt.
Yes, anyone? Anjali?
No, sir, no. No doubts.
Okay, anyone? Srikant?
No, sir, no doubt.
Okay. Next week, I upload the design handbook in Google Classroom. So you go through this and along with again upload 2 3 books. So you just go through this and you focus on PPTs. So this PPT will guide in right direction. So basically, this subject is concerned with piping industries. We call in piping oil and gas sectors, refineries, chemical plants, and petrochemical plants, and hydrocarbon plants. If you get good skill in this subject, definitely can place in different oil and gas sectors, refineries, and petrochemical chemical industries. So this is the basics what we are studying, all basics of piping engineering. So right now we are started and we'll cover in remaining lectures, and we are not hurry to finish syllabus in week or 2 week or 3 weeks. So we'll go slowly, and you must understand the all concepts of piping engineering. And in PPT, I have not written each and everything, as we discussed the method of connecting pipes as screwed connections. So here I considered only 3 methods and their respective names. I have not written the entire what we are doing in screw connections. So in notes, so whenever I'll upload, then you will get the all details in flange connection or in welded joints and everything material. So here we can compare the diameters, nominals, and NPCS size. That is we call the NPS. So earlier we call the IPS, and then in specifications in industry, in oil and gas industry in US, and then later they are designated this nominal pipe size. And if you are comparing here with DN and NPS, so in diameter, nominals, and nominal pipe size in inches. This is the difference. If you consider 8, that is diameter nominal. So if you convert into, that is 1 over 4 inch. So likewise, we can consider DN to NPS. So everything is given in design handbooks of piping engineering. So I upload, then you'll see the all tabular forms and the specifications of materials. And we are using the APL, all kinds of materials. Like here, we are use the API, the class. This we are considered the different kind of thicknesses that we are using wall thickness and as per designations of the schedule. So based on that schedule, so we can consider the SCH, stands for the SCH, and remaining the thickness, that is the standard thickness. And here a single XS means a single layer. And if you consider double X, you will consider the more strong as compared to single X. If you consider that kind of designation, then mention in ASME B31.3. So we can refer different kind of standards for piping engineering or process engineering. Okay. If you don't have any doubts or any questions, so I think we'll close this session. So we'll discuss in next session. Okay.
Okay, sir.
Okay, fine. Shall we close this, mate?
Yes, sir.
Okay, fine.
Yes, sir.
Yes, sir.